We are working alongside our lunar lander providers, preparing for Artemis II crew announcement and getting ready to begin stacking Artemis III this summer with a target launch in mid-2027. We are working alongside our many international and commercial partners to leverage the incredible capabilities from commercial industry to build a moon base. For all we hope to accomplish in this endeavor, what we are embarking upon is extremely challenging in this epic science of survival, because the moon base is as beautiful as it is hostile. In sunlight, the surface can heat to over 250 degrees. In darkness, it can drop well below -200. In the permanently shaded craters, areas of great interest that have been untouched by sunlight for millions, even billions of years, temperatures can fall well below -400 degrees. There is no atmosphere to moderate these extremes, no protection from radiation and solar particle events, and the surface is exposed to meteorite impacts, including the kind of light flashes the Artemis II crew observed from orbit. Why we send our astronauts into such harsh and dangerous and unforgiving environment of space or the lunar surface, and at such great cost. To inspire the next generation to do it better than we can, and to be very clear, to master the skills for where we will inevitably go next. So we are discussing 3 moon-based missions and a series of additional awards, with more missions to be announced in the months ahead. Now, Moonbase 1 will be the first privately funded lunar lander mission in history. The Blue Origin Mark I Endurance lander will deliver multiple payloads to the Shackleton Connecting Ridge, a strategic area of the lunar South Pole. In addition to flying 2 NASA science payloads, SCALPs, a lunar retroreflector array, the mission objective is to demonstrate critical capabilities that reduce risk for the human landing system missions. But this one is especially important because of the role Blue Origin plays in the Artemis program. The target no earlier than launch date is the fall of 2026. Moonbase 2 will be the largest commercial payload delivered to the lunar surface ever, though in this Moonbase endeavor, we certainly hope to be breaking records on nearly every mission. The Astrobotic Griffin lander will carry more than 500 kilograms of cargo, including Astrolab's FLIP rover, to the lunar surface. Moonbase 3 will expand our scientific understanding of the lunar surface. This mission will deliver the first payload selected through NASA's PRISM initiative, a program that brings together universities, researchers, and industry through open competition to solve scientific questions. The anchor scientific mission is Lunar Vertex, which will study lunar swirls, one of the moon's most intriguing mysteries. Now, these unusual formations appear brighter than their surroundings, as portions of the lunar surface are somehow shielded from the effects of the solar wind. Moonbase 2 and 3 are targeted to launch before the end of 2026. Now, these represent the first of more than a dozen missions we expect to announce through the balance of this year as we return, build the base, and never give up the moon again.
This is a chart that kind of describes the vision that we delivered during Ignition Day. We envision the moon base to be hundreds of square miles with different assets, all building up to the objective of permanent lunar presence on the moon. To get there, we're going to break it up in phases, and phase 1 has already started. From now through 29, we're going to work to make sure that getting to the lunar surface is a high reliability endeavor. When you think about the lunar surface and the endeavor of building a moon base, it's going to be extremely hard. And it dawns on us every day how little we know of the lunar surface. We did the Apollo program, we've had lunar probe, we've had spacecraft, robotic spacecraft that have gone back to the moon, but we have explored very little. So we envision multiple assets, those 21 landings, to deploy many types of assets in different areas where we have objectives for science, or we think it's a good place to develop the moon base. We're going to have landers, small and medium class. We're going to have constellations of satellites that will enable communication, navigation, pointing, observation. We're going to have rovers and LTVs. And also, we're going to have drones. NASA has selected Blue Origin. Blue Origin's lunar lander product line has 2 variants. Mark I, which is the uncrewed version, is what we're going to be using for the delivery of the LTVs, and Mark II, which is the crew lander mission. So using Mark I's will also reduce the risk for future crew missions there. Mark I is the same type of vehicle as Endurance, which is featured in Moonbase 1, the first mission to the lunar surface. Mark 1 type of spacecraft is also going to deliver the Viper rover later in the fall of 2027. The LTV will give astronauts the ability to further conduct scientific research around the moon. The LTVs will have a mass of about 1 metric ton, or a little bit less than that, and will have to be in a configuration that is kind of compressed to be able to fit on those landers. Each one of the vendors is going to do that in a different, ingenious way. They're designed to traverse about 200 kilometers from where they're dropped off, which is 4 times greater than any rover has ever traveled on the moon or Mars. These things can go up to 10 kilometers per hour and go up and down slopes of like 20 degrees. And that is Astrolab. Congratulations. Astrolab has adapted its Flex rover architecture to deploy the Crew Lunar Vehicle number 1. So give him a round of applause. Congratulations. This new vehicle is smaller, lighter, and can accommodate up to 2 crew, which is what we asked for during Ignition Day, to be able to test and develop the capabilities as we go. Again, it has autonomous capabilities, it can be teleoperated, or of course the crew will drive it. The second LTV provider, which I'm going to announce now, is Lunar Outpost. In response to NASA's moon-based initiative, Lunar Outpost unveiled a new class of rover called Pegasus, which is what we're going to deliver to the surface of the moon. Pegasus is a pared-down version of Lunar Outpost Eagle lunar terrain vehicle. Pegasus is a lighter weight and will be ready to fly on earlier missions as we've asked and demanded. Moonfall is the first lunar drone capability that we're going to have, and it's going to accomplish different objectives. The first is demonstrate the technology. It is going to be the first robotic mobile platform with the range to quickly explore sites interesting at the lunar South Pole. These drones will allow us to go, cover a broader range of areas that we prospect and get background truth. It can demonstrate the ability to take off and land in multiple locations with precision under South Pole lighting conditions and terrain features. It can go look into the surface of the moon about 1 meter in depth across tens of kilometers. It will also characterize the radiation environment before we send other assets or crews to the surface and provide a geodetic framework for navigation using retroreflectors. Wherever we put these drones, it will provide much more of a capability for precision lander for whatever landing is coming into that area. So high-resolution imagery across all mission phases, including the deployment, the landing, and nominal operations of staying in situ or hopping around. With 4 or 3 lunar drones, Moonfall, we're going to be able to basically put them at the corners of the areas where we think we have either key scientific objectives or we want to build up the moon base. And maybe in their final hope, like I said earlier, we can give them a function, potentially be a beacon, provide those retroreflectors to be able to get more precise landing, even be the first lunar cell tower if we choose to do so. The Moonfall drones has selected a carrier spacecraft, and that is Firefly. The Elytra vehicle will basically carry the drones from Earth into lunar orbit, then slow down, and at a certain altitude, it will deploy 4 or 3 drones that will then take the mission on their own hands. They'll finalize the landing. They'll land probably about a mile apart from each other and carry on from the mission there.